So folks, did everybody here get a chance to watch the recording of the earlier lecture?
I've actually had trouble accessing it before.
Okay. What I'd like for you to do is head on over to Blackboard and go ahead and check now. It should be available. I know I was getting emails from some of you and some of your classmates regarding not having access because although I posted the link, I did not make it accessible.
I could access it. I've been able to access it since like 6:30, I think. Not 6:30,
like
6:40 or something. Yeah, closer to 7. Yeah.
I think like right around 6:50 is when I made it accessible. So that would make sense.
I've only watched like about, I think, an hour worth of content so far. I'm still missing like a 10 minutes or so.
All right, I think the last 10 minutes are me. You should watch it. I think I maybe go through one problem with the earlier section, but we can talk about that now. Hold on, let me just address this. I got somebody emailing me saying that they can't log into Zoom. Make sure.
Oh yeah, I actually had to revisit the syllabus because I didn't realize that when you posted it on Blackboard, I didn't know that you had to put a password in for that class because most of the classes you kind of just sign in automatically.
What do you mean? You're saying for Zoom?
Yeah, so the link on Blackboard doesn't automatically sign you in. It prompts you for the password.
Interesting. You're talking about the link on the left panel.
Yes.
Okay. I wonder, because I also posted the link under the information tab on the same page as the syllabus.
Yeah, I tried clicking both, and for me it requested the prompt. Like the password prompt, yeah.
Okay. I will look into that. I mean, worst case scenario, that's what it is. I'll try again, actually. You know what? Let me do this. Copy invite link. Let me just open up a Blackboard page right now and see if I can fix that. All right, hold on. Let me see. Okay. Looks like we got some people joining us still. It's fine. Very good, very good. Okay. Looks like we are still missing at least one person. I have Andre emailing me, trying to get in. All right. So if you watched the lecture from the earlier part of the day, it might have explained some questions that you have. But if you didn't get a chance to watch it, let me just take a moment to introduce myself. Hi, everybody. My name is David Stern. You can call me David. You can call me Professor. But I don't think that we're ever going to get to the point where you can just come in and be like, "Yo, D-Dog, what's up?" But I'm good. I'm cool with David. So I am going to be your astronomy professor for this semester. I am also a high school physics teacher and astronomy and earth science. I teach over at Townsend Harris High School in Queens. And so I commute every day from Long Island City to Flushing, and it's nice because I get to drive against the traffic, which is always a good time. So let's see here. I'm wondering, before we pick up where the earlier lecture left off, if you didn't watch the video, it's okay. You can go back and watch it. Nothing that we really talked about there should preclude you from what we're going to do tonight. but you should watch that video also. No, Ian, I do not have either of those two people as students. But maybe one day you'll name somebody that I know.
Maybe.
Maybe. Okay, so with that, does anybody have any questions about sort of the structure of the class, whether it be from a how lecture is ran to grading policy, questions on anything? Is there anything that comes to mind at all?
Yeah, I wanted to ask, so the class would be divided in 3 sections, right? Where we'll watch like a video of some sort, and then the lecture, and then we'll go into like homeworks and like labs and stuff like that, right?
Yeah, so the class kind of looks like this, right? And let me just sort of explain it from like a big picture standpoint. I'm lecturing 2 sections of SCP-140. One of them meets Monday afternoon, one of them meets Monday night. Now, typically you're allotted, this class is supposed to be a 3-hour course per week. What I'm doing is I'm recording the first half of an SCP-140 lecture in the afternoon with that section, and I'm recording the second half with you guys. The lecture that I record with the earlier class will get posted right after. Today I had a hard time because I had to like set up my YouTube account, and it was just a whole pain. It'll be up earlier in the future. So I will lecture with them. I will post the recording of the lecture on Blackboard. Our class, which normally which is scheduled to start at 6:55, we will actually have a live Zoom at 8:15. And so the time between 6:55 and 8:15 is the time that I'm giving you all to watch the video from the earlier section's lecture. Right,
Okay.
so I will have recorded it. It will have been posted between 6:55 and 8:15. You are to watch the earlier class's lecture. At 8:15, you guys come into Zoom, and then we pick up right where that lecture leaves off. Right, which is why it's important that we watch that video before we come here. So next week we'll make sure that, also mind you, I've got my bearings straight now, but next week that video will be up sooner. You'll have time to watch it. Then we'll have our lecture. I'm going to try to keep it to an hour. If I find that I'm going over a lot, maybe I'll just decide that I'll cut something I was going to talk about that day and move it on to the next week's class. That way, there's also a little bit of time built in for you to ask questions about homework, about labs, about discussion questions, about any questions at all that you're having. And I will have time allotted for that. All right, so Dylan, I like your assessment that we're kind of breaking it up into 3 parts, right? One part is where you watch the earlier class's video. Another part is where you actually have your live lecture. And then the third part is just going over homework or discussion questions or whatever you want to talk about.
And that'll be from 9:15 to 9:45, right?
Yeah, I mean, sometimes lecture might spill into that time, but
Okay, yeah, cool.
if it is, that's just sort of the plan, right? Plans can change, but that's the plan.
All right, man.
All right, cool. Does anybody else have any questions that they wanted to ask?
I do.
Sure, Aman, what's up?
So I saw that you've also posted discussion questions that we have
Yes.
that are 8 o'clock on Monday every week. When exactly is that due, and when is the expected time frame that you expect that to be, like have a good amount of replies to?
So that's an excellent question, Aman, because obviously your ability to reply to another person's posts depends on their ability to post. So the discussion board question for any given week will open on Monday morning of that week at 8 a.m. And it will stay open until 11:59 on the following Sunday. So discussion 1 will close on Sunday, March 14th at 11:59 p.m. Right, so you got a full week. Except I think for the week there are 2 weeks where you'll have more than that. That's going to be the week of spring break, which is March 29th to April 4th or something like that. Right. So in that time, you'll have an extended week of discussion. And then Memorial Day weekend, Memorial Day is Monday, the 31st. So we will not be meeting that week, and the discussion will be, I believe I have it pushed to be 2 weeks long. That being said, you will, if there are ever any questions, you can always ask me. What I'm going to recommend is that everybody get their first discussion post in by Wednesday. I think that's just, if you think of it like you're all dependent on each other and you don't want to let each other down, right? You posting gives other people an opportunity to get their stuff together. Other people posting gets you an opportunity to get your stuff together. So you're all sort of dependent on each other. And that's why I think the discussion board is going to be very effective, right? I don't know. I don't remember if I explained this with the earlier class, but I'm not looking for yes, no, I agree, I disagree responses. I'm looking for more thoughtful, more
Elaborated responses.
Elaborated, thank you. More elaborated responses, exactly.
Yeah, you did mention it. I was just it's just that you didn't mention like, the time frame for it. So I was thinking between work and studies and things like that, like not a lot of time. If it's a short period, like 2-3 days, if no one posts, we might not have enough time, So
Right.
it's a
But
good
we
thing
also-
that, thank you for having a week,
You're welcome. But we also don't want to see people waiting until Friday night to post and then everybody's scrambling on Saturday and Sunday to get their replies in.
Mhm.
Right. So the idea is get it in early. I mean, I'm trying not to make these questions too crazy. They're all fairly open-ended. You'll find as they open up each week, because I already have all the questions created. They're just set to a timer. While I have you all here, what I'd like for you to do is go on Blackboard and click on the Homework and Labs tab. And I'd like for you to try to open the first homework assignment. Right, it's called First Problem Set, Visual Astronomy and Calculations. Let me know if that opens for you. Because earlier, it wasn't working, and then I went in and I changed something, and it should work for you now, but I'd like confirmation before I send you guys off for a week.
So if you press launch, it seems to launch. There's a start button and it says it's due by Sunday. So I don't want to press start. So
right. So
mine didn't open.
Are you on a Mac?
No.
What browser are you using?
I'm on like Google Chrome.
Does it give you an error as to why it's not opening?
No, it says ask my teacher about it.
Would you mind screenshotting that, Dylan, and sending it to me?
Actually, I think I might refresh it. What if I like refresh it? Maybe I just need to
try it.
refresh
Yep,
it.
that might work. Maybe.
Well, I'm on a Mac. I'm on a Mac and it says it. So should I go to Google Chrome instead?
No, if you're on a Mac and it says that it's not working, you have to click on Safari on the top of the screen.
Okay, now I see it. Yeah, now it came up.
Great, Dylan.
Right.
Daniela, click on Safari, go to Preferences, click on the tab that says Privacy, and if the box that says Prevent Cross-Site Tracking is checked off, you have to uncheck it.
Oh, okay.
And then it should work.
Okay.
All right. Now, personally, I'm only ever going to turn that off when I'm going in to do my open math. Otherwise, as soon as I'm done with that homework, I'm going to turn that back on, and I would advise you to do the same.
Okay.
Just for your own your internet security and whatnot.
Right.
Ian, you got a question?
Yeah, I'm actually a little bit lost. Do you think you could probably
You want me to screen share it?
Yes, please. That would actually help me very, very much.
No problem. Are you having trouble locating the homework?
Yes.
Okay. So take a look here. let me actually get you onto the, so you have to be on Blackboard.
which I'm already on.
All right, you got our homepage. On the left side here, there's homework and labs.
Homework and labs. Hang on a second. Oh, I see.
All right, you click on that, and then here are all the homeworks. Now, the only thing that I'm having trouble with is getting the due dates to show up on Blackboard. But if you follow the syllabus, due dates, those are the due dates that are going to be for the semester. Like those are the correct dates for all of the homeworks and labs. Okay. Before I forget, one other thing that I'd like to do, this is going to require, hold on one moment. This is going to require a little bit of help from everyone. I'd like for you to change your name on Zoom. So if you can click on your name in the participants list, or I think if you hover your mouse over your name, there should be 3 little blue dots on the top right corner. And when you click on it, it allows you to rename yourself. And I would like if everybody here could just add at the end of their name what their pronouns are. I don't know if you've ever done that before, but
I indeed have.
you have. That's good. I think it's important. Whether you identify as binary or non-binary, I want to make sure that you feel respected in this space. So whether you are he, him, his, she, her, hers, they, them, theirs, doesn't matter. I want everybody to have their pronouns up so that we can all, refer to each other appropriately. All right, so thank you to those of you that have already done it. Those of you that haven't done it yet, let me know if you're having trouble figuring it out. Okay. Let me see. Yep, and if you just, like Mario just put him, that's fine. I know that's he, him, his. Daniela just put her, she, her, hers. I got it. Excellent. All right, but I see some of you have not gotten to it yet. Just please let me know if you're struggling with that, because that's something that I'd like for you to do every week. Whether you're in a class full of people that identify or use binary pronouns or not, it's still just important to normalize doing this, especially for the people that do not and that are not binary and feel like the world is against them. I think it's very important. Okay, so with that, folks, let's get into some of the things that were talked about in the earlier section. Actually, just give me one moment. I still have a student that's trying to log in and is struggling. So I'm just going to send the meeting ID and passcode to them. Please hold one moment.
All right, Professor.
Yeah,
Are these meetings also going to be posted onto Blackboard?
they are, because the other class is going to watch the video from this.
Yeah, that's what I was just, yeah. Okay, thank you.
You're welcome. Okay. So let me see here. Okay, so in the last lecture, again, just show of hands, you can use the reactions on Zoom. You should be able to see them on the bottom of your screen next to the share screen or the chat button. Using the reactions, could you just give me like a thumbs up if you did watch the earlier lecture? All right, awesome. All right, Jareen, tell us one thing that you learned from the earlier lecture. What was one thing that was spoken about?
Okay, so I learned what astronomy is, the definition. So the study of celestial objects such as moon, planets, stars, and galaxies.
Yes.
And then the topics. the day and night sky, the seasons, the starlight, properties of stars and planets, formations of the solar system, black holes, galaxy, modern cosmology. I think that's
Yeah, you did.
okay.
All right, so wonderful. Thank you, Dorian. Let's see, James, what did you learn about from the earlier lecture from today?
Actually, how the exponents on like how to like put Jeff Bezos' net worth.
Yeah, that's right. Yep, we were talking about how to use scientific notation, right, which is going to be really important for talking about large numbers and small numbers. So I'd actually think that it would be worth our time to do a little bit of practice with scientific notation. And then I don't plan on keeping tonight's lecture particularly long. I don't think that we're going to make it to 9:15. I think that it'll take a little bit less time. And then and that will include like going over some homework problems if you'd like. All right, so I'm going to share my iPad screen here. Okay, all right. And just a reminder, I see that some of us still have not added our pronouns to our name. So if you wouldn't mind just going ahead and do that, this is a gentle reminder. Okay. Let me see. Can everybody see my screen? There's nothing written on it, but it should look like a little whiteboard.
Yes.
Awesome. Very good. Okay. So let's say, let me actually start here. I'm going to write down some numbers, big and small, and we're going to write them out a couple of ways. We're going to write them in standard notation and scientific notation. And we're also going to attach to that the metric prefixes that are associated with that size number. I believe that if you go into My Open Math and you open up the first homework, that you can actually get a table similar to the one that I'm about to draw. Okay. So let me see here. Okay. So we have 1 over I forgot a set of zeros. So 1 over a trillion is a trillionth. The metric prefix that we use for things that are on this order of magnitude is pico. Let me just add a little title here. I'm copying this straight out of the homework, the first homework set. So if you'd like to just look there, that's fine. But this might be something worth having written down that you can just quickly open up to. And in scientific notation, we write that as 1 times 10 to the negative 12th power, or even just 10 to the negative 12th. All right, then we've got 1 billionth, 1 over a billion. All right, so that's a 1 followed by 9 zeros. The metric prefix is nano. And the scientific notation is 1 times 10 to the negative 9. What I'd like to point out is that the power of 10 in scientific notation, right, very good, Ian, I saw in the chat. The power of 10 in scientific notation here is related to the number of zeros in the original number. Right, so you'll notice that 1 trillionth, 1 over a trillion, has 12 zeros in it. And so we have 10 to the negative 12th power. And let's just keep going and decreasing the number by 1,000, or excuse me, we're not really decreasing the number. We're actually getting into bigger numbers here.
How do you determine the metric prefix?
So the prefix is just something that needs to be memorized. This is something, so the prefix is assigned to one of the powers of 10 of scientific notation. And the use of the power of the prefix is that it saves you from having to write, like, I'll give you an example. 1 kilometer is 1,000 meters. Right, one nanometer. I'm just going to write this off to the side somewhere that it's going to be out of the way. 1 nanometer is 10 to the negative 9 meters, which also could be written as 0.00000000001 meters. Right, so I'd much rather write that as 1 nanometer than 0.000000001. Like, it's just way less. It's way less writing to use the prefixes. So let me just get that off there for a second. We'll come back to that. All right, so millionth. This is micro. 1 times 10 to the negative 6. Right, so when we talk about things that are like microscopic, right, that's talking about things that are around 1/1,000,000th the size of a meter. Right, so if you took a meter stick and you broke it up into 1,000,000 little pieces, each one of those is a micrometer. Then we could do 1 over 1,000. Right, this is 1,000th. The metric prefix is milli. Oop. 1 times 10 to the negative 3. Right, like a millimeter. A millipede has 1,000 legs. Millimeters. There are 1,000 millimeters in 1 meter. And we can continue to break that up. We can go into hundredths. Right, which we use centi. Right, a centimeter is 100th of a meter. That's 1 times 10 to the negative 2nd power. We have a tenth, which is the metric prefix is deci, like a decimeter. 1 times 10 to the negative 1. Then we have just 1. There is no metric prefix for that. But there is a scientific notation. It's just 1 times 10 to the 0. On a side note, any number that's raised to the 0th power is equal to 1. So like 10 to the 0 is 1. 50 to the 0 is 1. 997.6 to the 0 is 1, etc. And you'll notice that sort of as we're going down this list, right, we're getting larger. Right, the numbers are getting larger as we move down this list. Right, even though we wrote 1 over a trillion, and a trillion's a big number. 1 over a trillion is a small number. 1 over a billion is a larger number because that's a bigger fraction. And so we're going to keep going down, and we got 10, 1,000, oh, I skipped 100 because I was not paying attention. 100, 1,000, 1 million, 1 billion, 1 trillion. Oops, got an extra 0 in there. So we got 10, 100, 1,000, million, billion, trillion. All right, going down the list of metric prefixes, we have deca, D-E-K-A. We don't really talk about deca all that much, but it's a thing. Hecto. Now we're going to get into the ones that you probably recognize from the size of your computer files. Kilo, mega, giga, tera. Right, so if you're talking about like, you're going to buy a fancy new computer, the hard drive might have a storage space of, 512 gigabytes, 256 gigabytes. Maybe you got a terabyte hard drive. Maybe you've got a 2 terabyte hard drive. Maybe you've got that one text file that's like 56 kilobytes. Ian?
Yeah. Is it all right if I answer what's supposed to be on the rightmost column?
Yeah, go down the list for us.
All right. So 10 should be 1 times 10 to the first power.
Okay.
Yeah, because 1 times 10 is 10, and yeah.
Yep.
And then 1 times 10 to the second power would be where 100 is. From there, it would be 1 times 10 to the third power for 1,000.
Very good. Keep going.
For a million, it would be 1 times 10 to the sixth power.
How did you determine that one?
Essentially, I looked back on my notes for what you did for 1/10th, 1/100th, and then I guess it would be considered descending for that. And I basically just switch them around from a negative to a positive spin.
Okay, so you notice that there's a little bit of a pattern to this chart.
Yes,
right,
indeed.
in the way that we're doing it, right? So if we keep going, we should have 1 times 10 to the 9 and 1 times 10 to the 12th power. All right, so what we're saying here essentially in this last line is that 1 trillion is equivalent to 1 times 10 to the 12th. Those two numbers are the same number. They don't look the same. One of them looks a lot easier to write, and that's the one that I'd rather be using. But to determine what power of 10 we're talking about, we have to look at how many zeros or how many places come after the first non-zero number. So the first non-zero number is this 1, right? The first non-zero number is this 1. So we're gonna move the decimal place from its position after the 1's place all the way on the right, and we're gonna move it over until it's right behind that number 1. So we have to move it over once, twice, 3 times, 4 times, 5 times, 6 times, 7, 8, 9, 10, 11, 12 times until it's behind the 1. And that's how it's determined that the power of 10 associated with a trillion is 1 times 10 to the 12th. Now, when we're talking about a trillionth all the way at the other end, I wrote it here as a fraction, but I could have written it as a decimal if I wanted to. And I'm going to write it as a decimal, and that might even make more sense. All right, 1 trillionth looks like this. Okay, the number on the top left, that is also 1 trillionth in standard notation. Now, to put this in scientific notation, we're going to do the same thing that we did at the bottom, where we tried to move the decimal point so that it comes after the first non-zero number. Well, the first non-zero number is all the way over here, and we want the decimal point to be behind that. So how many times are we moving the decimal over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times. But notice how here we moved the decimal to the right, and at the bottom here, before we moved the decimal to the left 12 times. Right, so we're taking, so if we multiply 1 times 10 to the negative 12, that would turn it into a smaller number. And if we did 1 times 10 to the positive 12, that would turn it into a bigger number. Okay. That's going to be something that's important. Let's try, I'm going to introduce one other thing that right now before we move on and try a practice problem or two. I want to teach you how to convert between units. Okay. Let's say that you want to convert from, oh, I don't know. Let's say that you want to convert from inches to miles, right? And you had to show your work on paper. So you can't just be like, Alexa, how many inches are in a mile?
1 mile is 63,360 inches.
And expect a response, right? You can't just do that, right? So if you have to show your work for it, how does that happen? What does that look like? So let's start with a mile, okay? We want to know how many inches make up 1 mile. So we're going to write 1 mile, just like that, right? MI is the abbreviation for a mile. We'll come back to prefixes in a second. Now, let's say that we don't know how many inches are in a mile, right? We can't, we don't know how to convert from one to the other, but maybe you know how many feet are in a mile. Just out of curiosity, does anybody know how many feet are in a mile?
Yes. The answer is the answer is 5,280 feet.
That's correct. So if 1 mile on a side, I'm just going to write this off to the side here. 1 mile is equal to 5,280 feet. All right. Then what I'm going to do is I'm going to take our original number and I'm multiplying it by a conversion factor. Okay. This is not just useful for astronomy. This is just a skill that is important if you're converting units for anything. Okay. What the conversion factor does is it changes the unit that you're in without changing the value of what you have. So let's say that we want to multiply this by something that gets us out of miles and into feet. Well, you see how miles is in the numerator? In the fraction, we're going to put miles in the denominator and feet in the numerator. And I'll get to why we do that in a moment. Now, we set up above that 1 mile is equivalent to 5,280 feet. Now, I'm going to put something out there and I want you to tell me how uncomfortable this makes you. I'm going to say that this conversion factor is equal to 1. Does that make anybody uncomfortable? Is the world as you know it crumbling before you?
Absolutely.
Absolutely. So numerically, it's not equal to 1. All right, numerically, this is equal to 5,280 divided by 1, which is just 5,280. But if we're thinking about it in terms of the value of the numerator compared to the value of the denominator, they have the same value. So what happens when you divide something by itself? It's 1, right? So the value of this conversion factor is 1. And when we take 1 and multiply it by the number that we start with, it doesn't change the value of what we've started with, right? We still have 1 mile when all is said and done. So watch what we're going to do next. We're going to multiply this by another conversion factor. Because remember, we're not trying to get from miles to feet. We're trying to get from miles to inches. Now, the first conversion factor is going to get us out of miles, right? They're going to cancel. And now we're in feet. It's like magic. And I know that everybody here knows how to get from feet to inches, right? What's the equivalence there? 1 foot equals
12 inches.
12 inches. So in this conversion factor, we're going to put 1 foot in the denominator and 12 inches in the numerator so that feet cancel. Right? All of the units now have canceled except for inches. So we've now converted. Now it's just a matter of multiplying all of these fractions through. So this is 1 times 5,280 times 12 divided by 1 times 1 inches. Right? And so we can get out a calculator or whatever you're using for your calculations. Maybe you're using your phone. 1 times 5,280 times 12 divided by 1 gives you 63,360 inches. That's how many inches are in a mile. Right? And so you've all just done your first, at least in this class, your first conversion factor. Now let's go ahead and let's write this number in scientific notation. All right, so this is standard notation. And if we want to put it in scientific notation, that means that we have to move the decimal so that it's behind the first non-zero number. So we're going to take the decimal, which is after the 0, right? The decimal is currently after the ones place. And we're going to move it over 4 times. We're going to put it after the 6 at the beginning. And we're going to now multiply this by 10. Well, since we moved the decimal place 4 times, we have to put a 4 up here. But the question is, should that 4 be positive or negative? What do you guys think?
Would it be negative because like you're making it smaller?
So that's a good thought. I like that. And let me just make sure I'm pronouncing your name right. Angelina? Angelina?
Angelina.
Angelina. I'm so sorry, Angelina. Okay. Thank you for correcting me. So we did make the number smaller. But remember, this is supposed to represent 63,360. But this number is way smaller than that. So we have to multiply it by something that's bigger to get it back to that original number. So, Angelina, how does that change your answer?
Then it will be bigger.
So this 4 has to be positive,
Yeah.
right? Because 10 to the positive 4th power is a large number. 10 to the negative 4th power is a very small number, right? That's a fraction. Okay, so Here we've converted into scientific notation. I was wrong about ending before 9:15. My timing is all sorts of off right now. It's okay. It's because we had some questions and stuff that we needed to address. Okay. So let's see here. Let's say that we wanted to convert this number we wanted to rewrite it in scientific notation. Can somebody talk us through how we do that? Preferably somebody whose voice I have not had an opportunity to hear yet. This way everybody gets a chance to talk tonight. All right, we got to make sure starting this semester off strong, we got to build that community, that culture of using our voices and not just sitting there. Let's see, Mario. Cold calling.
Yep.
Do you think you could talk us through how to put this in scientific notation?
No, to be honest, I'm kind of confused.
Kind of confused. All right. Teisuke, can you help us out?
I guess we can use micro, right?
So we're not putting the so you're actually a step ahead of me. You're a step ahead of me. We're not up to the prefix yet.
What's the question here? I'm sorry.
So we want to take this number and put it in scientific notation. And I think Schnorr actually beat you to the punch in the chat.
Oh, okay. Yeah.
So I'm going to ask you about what you said a moment ago in 1 second. When we write this in scientific notation, as Schnorr said in the chat, and I apologize. Excuse me. I apologize if I'm mispronouncing your name. Please correct me if I am. But we're going to write this as 1.234567. Right, so we've moved the decimal point over so that it's behind the first non-zero number. The first non-zero number is 1, so we moved it behind the 1. And because we moved it over 6 times to the left, we're multiplying by 10 to the positive 6th power, which I see Dami or Daimi. How'd I do?
Daimi.
Daimi. Sorry. Thank you for correcting me, Daimi. Also said in the chat is 1.234567 times 10 to the 6th power. Now, and let's just say that this is measured, I don't know, maybe we're measuring in grams, right? Grams, right? Then Taisuke, how do we then adapt this to include a metric prefix?
What do you mean? I'm sorry.
So how could we restate this number with a metric prefix instead of a power of 10? So you were saying something before that I really liked. I said you were a step ahead of me.
Right.
I think, yeah.
I said nano. Yeah.
You said nano. So where are you getting nano from? And how are you? Yeah. How did you decide nano?
Just how many digits there are after the 1. So it's 2, 3, 4, 5, 6, 7, 6 digits.
So
that will.
I see what you're saying. Okay, so we're not going to go by the number of digits that come after the decimal point, because you could have a number like pi, right? Everybody here knows the number pi, 3.1 3.14, but it's really a, like an infinitely long number, right? It's like 3.1415926535889 something something something, and it goes on forever and ever and ever and ever. And so a number like that, you wouldn't count the decimal points because you'd be going forever. The number that we care about is this, 10 to the 6th. All right, we're going to look at that power of 10 and say, which metric prefix does that correspond to? And I see Schnorr in the chat is already a step ahead of us. I'm going to scroll back up to this chart that we had. And we see we've got 10 to the 6th right down there at the bottom. The metric prefix associated with 10 to the 6th is mega. Mega with a capital M. So we can rewrite this as 1.234567. And now instead of writing times 10 to the 6th grams, we're just going to get rid of the 10 to the 6th and replace it with the prefix mega, which means 10 to the 6th. All right, so these two are equal. Okay. Hold on one second, Angelina. I see you've got your hand up. Let me just see. Andre made it. Welcome, Andre.
Hi, Professor. Sorry.
It's okay. It's all right. We got it. Now we're all set for next time, right?
Yes.
Great. So Angelina, what's your question or comment?
I got like a little bit confused because like how come we can't use oh gosh milli? Because like I'm looking at like oh wait, not milli, I meant micro. Yeah.
Micro. So that's a good question. Okay. So first it's important then to understand why this is 10 to the positive 6 and not 10 to the negative 6. So is that something that you want me to go over again? Okay.
Yeah.
So we have this number, okay? The number that we're starting with is 1,234,567. That's a big number. I wouldn't mind having that many dollars in my bank account. Now, when we are converting it into scientific notation, we're moving the decimal point so that instead of it being behind the ones place, it just comes after the first non-zero number, right? So to make that happen, the decimal point, which was originally after the 7, had to be moved over 1, 2, 3, 4, 5, 6 times. Okay. In doing so, we made the number smaller. So we have to multiply it by a power of 10 that will get it back to its original size. Right? So 1.234567 is a small number. We have to multiply it by 10 to the positive 6, which is a big number. Right? 10 to the positive 6 is 1,000,000. Right? 10 to the positive 6 equals 1,000,000. So really, we're doing 1.234567 times 1,000,000. See it now?
Yeah, yes. Thank you.
You're welcome. And so once we get to that, right, once we then recognize what power of 10 we're using, whether it's positive or negative, then we say, oh, which metric prefix is associated with that power of 10? Right? And that's mega in this case. When we talk about, I want to drive 30 kilometers to get to my friend's house, we say, well, how many meters is that? How many meters is 30 kilometers? Well, a kilo represents 10 to the 3rd power. So let's drop the kilo and multiply this by 10 to the 3rd. These are the same things. I just rewrote the same number 2 different ways. And then if we multiply 30 by 10 to the third, 10 to the third is 1,000, right? We get this, right? So 30 kilometers is 30,000 meters. All right. There will be some opportunities to practice that. All right. Before we finish going over some concepts tonight, I want to share something with you guys. And this is, you know, the people that are watching this via recording, you can do this on your own time. I think that this is a fun thing to do, especially if you then like go to family or friends and you're just like, haha, see, you know nothing, I know everything. You'll get a good time. You'll have get a kick out of this, excuse me. I want you to take a piece of paper, right? Get a piece of scrap paper somewhere, loosely lined paper, you know, whatever, graph paper, printer paper, and I want you to hold it sideways, right? Hold it like this, okay? Landscape style. All right, and I would like for you to map out where the different planets in our solar system are. So I want you to assume that you have the sun located at the top left corner of your paper and Pluto located at the top right corner. All right, I want you to mark those two like I have marked on my iPad screen. All right, and we're just going to assume that all of the planets are between the sun and Pluto. Now that's not the case on the day-to-day because the orbits around the sun are circular. So you could have like the Earth on one side of the sun and Mars on the other side of the sun and Saturn on one side and Pluto or you know Jupiter on another, all around. And we'll explore more of the solar system's structure later on in this course. But I want you to take this and I just want you to start marking it up, right? If you don't remember the name of a planet, you can ask. If you don't remember the order of a planet, do your best, try not to look it up. All right, try not to look it up. It's more fun that way, I think. All right, I'm not grading this. This is not a graded assignment. This is just to get you thinking about how far apart are things in our solar system? How far apart are the different planets? All right, so take a moment, get a piece of paper. I'm gonna kindly request that once you do this, you turn your video on and you hold your paper up, just so we can see where you marked off on your paper.
Just want to let you know, I actually don't have a piece of paper, but I know what is the closest planet to the sun and then, you know, the farthest.
Okay. All right, that's excellent. All right, so what I'd like for you to do then is if you, what's actually a good way to do this?
One side of my head to the other?
One side of your head to the other, that's funny. If you go to, I think there's a website, Canvas. If you go to Canvas, is that it? Nah, damn, I can't remember what it's called.
I mean, he might be able to just, if he's using a laptop, he might be able to open up like Paint or something and just draw it. And then upload the file to chat.
Not a bad idea. Absolutely. Absolutely. Or you could even go to sketch.io. I'll put the link in the chat if you are without a piece of paper.
Is this like Agarrio?
I'm not sure. I've never used Agarrio, but it's just like an online, slightly more limited version of Paint. All right, and so maybe you just want to like draw a line across your page, a horizontal line to the best of your ability. Doesn't have to be perfect. And then mark that up. All right, how many of you are looking at this and like I have no idea what the names of the planets are?
Honestly,
I'm so confused.
Scrambled.
yeah, like
Couple
I
of
don't
us?
even. It looks mad weird. Like,
Well, what does that mean? What does it look like?
would you like
You
to
know-
see?
I would. Can you hold it up for us?
It's like I don't even know if you can see it.
Oh, so hold it. So maybe I wasn't clear. What I'd like for you to do is like here, and I'm going to draw this on my screen, and I'm not saying this is right or wrong. So on the top edge of your paper, I want you to put like a line and be like, you know, Jupiter.
Oh, so like point arrows out and
Yeah,
stuff like that.
point arrows or like put little tick marks or something, right? I want you to locate approximately where in between the sun and Pluto would you find the other planets, right? So maybe you're thinking of in terms of like distance from the sun. Angelina?
Like an order? Like
Yeah. So put them in order, right? From closest to farthest. But the real reason I'm doing this is because I know for a fact that most of us will not get the distances correct. And that's really what I want to point out.
Like,
I'm sorry, Daniela, did you say something and I missed it?
I said definitely not, because I feel like mine's are jumbled, like the order.
What
so
order
is it
do you
supposed
have?
to be like this?
All right, I'll show you. Let me see.
So
Or is it
Dylan, bring
not?
it a little closer.
You see mine? Oh,
Oh yeah, no, I see Daniela's too. Here, so actually, Dylan, if you look at Daniela's, that's what I'm going for. All right, so like little lines towards the top.
So little line. I drew like, oh man.
Just saying where they are, right? So if you look at Daniela's, right, and let's just go with this for now, right? It looks like starting from the sun, just bear with us, Danielle. Starting from the sun, moving over to the right, it looks like the spacing as you go from one planet to the next pretty much stays constant. Is that a fair assessment, you think? Except for let's see, what's the last one? Right, you got Neptune.
Yeah.
So from Neptune to Pluto, you got a little bit of a gap there.
Mm-hmm.
Okay. Let's see. Ian, you want to share yours with us?
Yes, indeed.
Let's see it.
All right, hang on.
Do I have to enable screen share? Is that what needs to happen?
Yes, indeed.
All right. Here you go.
Oh, yeah. Also, I kind of did it vertically because I couldn't find the eraser. And
Fine. We'll I'm sure we'll be able to make sense of it.
all right. So yeah, basically from top to bottom, left to right.
Really? You wrote Uranus? Really? Give me back the screen share, man.
Oh my
Get out
God.
of here. I'm stopping your screen share. Jesus, come on, man. There are children somewhere in the world that might watch this one day. It gets posted on YouTube. All right, no, you missed the mark a little bit there because we weren't just listing them, right? We're not just listing the names of them. We're showing where their relative distances are on a line. So what I'd like for you to do, if you have your paper now, I want you to fold it in half. Let me show you how. I want you to fold it in half this way. Okay. Fold it in half. What was that, Daniela? You're muted.
Oh, you read my lips. From the planets on the outside? Like, am I
Doesn't matter.
Okay.
It won't matter. It won't matter because you're going to unfold it afterwards. So fold it in half once, then fold it in half again, then fold it in half again. All right. When you open it up, you should have 8 sections. Okay. So let me just mark this up on my paper. So you should have 8 folds, or rather 8 sections. It should look something like this. I'm eyeballing mine. All right, so let me just put that there, this there.
Professor, can I show you?
Yeah, absolutely.
Mm,
And then I'll share my screen so you
I
can
don't
see
know
what I
the
got.
name, but I remember the picture is like the
Hold on, bring it a little closer because it's hard to see with the lighting.
planet is the sun, and they are.
All right, so you were actually
Okay.
you're starting to draw the actual like orbital paths.
Yeah.
Or you're like drawing the rings, right? So you're way more advanced than what I'm asking for. So here, check this out. Just give me one more second to draw my lines here. Okay, I'm gonna share my screen now. Okay. Can you guys see?
Mhm.
Okay. So here's what we've got. This might make you sad. I'm not entirely sure. At the first fold, we have Jupiter. At the second fold, wait, let me just zoom in a little bit. At the second fold, we have Saturn. Okay. So at the first fold, we had Jupiter. That's about 1/8 of the way across. At Saturn, which is about 1/4 of the way across. Half the way across. Oop, did not mean to erase that. Half the way across, we've got Uranus. Not Uranus. Uranus. To Ian. Put those away, man. Put those away. And then at 3/4 of the way, or the 6th fold, we have Neptune. All right, now we're gonna zoom in. I'm gonna zoom in on my screen just so that you guys can, and I'll then zoom back out. But I'm just gonna zoom in really quickly over here into this tiny little section, because I'm actually gonna go onto the top part of my paper for this. Really want to make sure that I get this right. You have Mercury, Venus, Earth, Mars. All right, so I'm gonna zoom out again just so that we can look at this in its entirety. Okay. And for all the pictures that you've ever seen of the solar system with all the planets, definitely not drawn to scale, right? This is a pretty accurate scaled down map of the relative distances between them and the sun. All right, so just look at how close those first 4 planets are, right? And I know Daniela is not the only one, right? But Daniela had Earth like somewhere out here, you know, like past where Saturn actually would be on this scale.
Oh yeah, I put Earth in the middle of everything.
Right. So I think that this is sort of a bit of an eye opener for a lot of people that are studying astronomy for the first time. Like, oh my God, like this is not at all what I thought our solar system, where we live, right? Like this is part of our cosmic address. You know, like you have your street address, you have your city, you have your state, you got your country, then you've got planet Earth, then you've got the solar system, right? Then you've got the Milky Way. And that, you know, we can keep saying where we are in the universe by taking it one step higher. So, you know, it's important, I think, to know a little bit about our home, yeah, and like our solar system, right? And with that, folks, I am done with my lecture for tonight. So I'm going to
I
stop my
wanted to
screen
ask.
share. Yes.
Sorry, I
Dylan.
wanted to ask. So there's nothing between Saturn and Uranus between Neptune. That's just blank.
Well, there are things. I mean, nothing major, right? But you have like comets and asteroids, right? There are other objects that sort of float in between. You know, the asteroid belt is, you know, is mostly up in this region right here between Mars and Jupiter. You know, out here, you have the Kuiper belt, which is where we find a lot. We'll get there. This is all stuff that you're going to learn in this class, right? That, you know, that's where you're going to find the bulk of our solar systems. Well, not the bulk, but many of the comets in our solar system are out there with Pluto, just floating around. And then there is stuff in between, you know, like it's not like totally empty. Right? There's dust floating through space and this and that. And we're gonna talk all about it. All right. So I hope that this that, you know, you're excited about this class. Even if you're not looking to become an astronomer or, you know, go work for NASA or, you know, SpaceX or whatever, that, you know, you can walk away from this class, you know, saying that you learned something about our universe, right? That's really what the point is, right? I'm on. Okay, so with that, folks, I'm going to stop my screen share. I'm going to stop the recording. And then if anybody has any questions, feel free to stick around. And if you'd like to head out, you can head out. All right. Thank you, everyone.